Our next speaker is Peter Cockcroft from Adelaide, South Australia, and he's going to talk about advantages and disadvantages of using colostrum as a sample type.
Okay, good morning everybody. I'm going to describe quite a small study where what we're looking at is using an alternative sample type with a map ELISA, and we're interested in looking at the performance that we get with colostrum. Just to give you some sense of geography, I work and live in Adelaide, which is here in South Australia, and our trial herd was actually in Victoria, adjacent to that state. I'm not getting a...
Okay, if you just ask them to move the slides on, they'll move them for you.
Yep. Okay. By way of introduction, I think we've really had most of this before this morning. Obviously, Johne's is an important disease. I think we've got that from the previous talks. I think the key thing to emphasize in our study is that it's obviously got a long incubation period. And the key epidemiological feature is that it's really, really quite difficult to identify incubating and subclinical animals. And really that's the critical thing that we need to do. I think we've already heard talks about the immunolinked, immunosorbent analysis test, and I think the point has been made that it is very low cost, it is widely used. And if we look at Michael Reichel's paper from 1999, if we look at the sensitivity of that test in relation to the shedding, the map shedding, we can see there's quite a lot of variability. In other words, low shedders give really quite low sensitive results. This study was really predicated, and it's something that we all know and we're all taught about, on the fact that colostrum contains quite high concentrations of immunoglobulin, and I've just put up some examples of what that difference is. If you look at that first line, if you look at IgG1, you can see compared to serum that colostrum contains maybe 5 times the concentration of colostrum. And in fact, it can be much, much higher than that. And therefore, you might anticipate that if you've got a higher concentration of immunoglobulins, that you would get an increase in sensitivity of any particular test that's using immunoglobulins. We did some prior work with this concept in mind, and this is some data that we published, and this is looking at some sheep that were vaccinated with our licensed vaccine in Australia against sheep, which is the Guida vaccine from Spain. It's a killed vaccine. And if we look at this graph, if we look at sample dilution on the bottom axis there, and we look at the diagnostic sensitivity, what we can see really is quite a large step up in the sensitivity when we use colostrum. And in fact, if I showed you the graph with whey, where you extract the whey using renin from that, you get an even bigger increase in that sensitivity. So we already had some background data to imply that maybe there could be an increase in sensitivity if we looked at colostrum as a sample type. So that's our aim. I've talked already about our aim. We were interested in looking at the performance parameters of colostrum as opposed to serum using a MAP ELISA test. Materials and methods. We identified a farm, a dairy farm, a Jersey herd that had a previous history of Johne's. We got that farm, we got the farmer to collect colostrum samples from newly calved animals in the first 24 hours postpartum. We collected 34 samples in total, and then what we did 30 to 60 days postpartum, we simply went on farm, or we got a veterinary surgeon to go on farm and bleed the cohort that we'd taken those samples from. Now, you may well say, well, why did you dislocate the bleeding samples from the collection of the colostrum? Partly it was physical, and partly it's to really not, partly it's to be very conservative. If you look at serum levels around parturition, you get a big dip in serological antibodies, and the recovery phase is 30 to 60 days out from that. So in other words, we're giving serum every chance to perform as well as it can. We also took fecal samples, and we ran those fecal samples with the HTJ PCR, and we also did fecal cultures, the gold standard or the reference standard for Yonis. I'm not going to go through the test on the side because time is ticking away from me, so I'll slip over that slide. What we did do is work out the parameters, which is the sensitivity and specificity. And I've got a fairly mixed audience. I think people often rattle through quite quickly what these are, but the sensitivity is really the proportion of animals that have got the disease that give a positive test. And the specificity is the proportion of the animals that don't have the disease that give a negative test. And that's described in these two equations. And just to remind you, we're using the fecal culture as our reference standard. This is just looking at the HTJ PCR results against the fecal culture. And what you can see here is we got no positive results with the HTJR across the positives or the negatives. In other words, it couldn't pick up any negatives. With the fecal culture, we had 4 positive animals on fecal culture and 30 negatives. So effectively, HTJR gives sensitivity of 0 and a specificity of 100%. This is a very busy slide, but this is the kind of study, this matrix is what you do when you're trying to parameterize a test. You look at various dilutions of each sample type. You look at a range of different cutoff points, and then you measure how many positives and negatives that is giving you, depending which cutoff point you're using. So I want to really focus on this interesting area at the top there. And I've just teased out the samples from that. So we've got serum here, and we've got colostrum here. We've got disease, positive and negative, positive and negative. And with serum, it gave us no positive results whatsoever across positives or negatives. And if we look at colostrum, it gave us 3 positives and 1 positive, 1 negative there, and 3 negatives there, and 27 negatives there. Let's just collate that data and see what that means in terms of sensitivity. So if we look at, and this is a small amount of data, be very careful here. If you look at the confidence intervals, they're very, very wide. So we're looking at a trend here, so be very careful on the evidence that this provides. But if we look at colostrum, we get a sensitivity of 75%. If we look at serum, we get 0. Looking within that matrix space, a dilution of 1 in 5 and a sample to positive cutoff ratio of 0.015. If we look at the specificity, the colostrum, we get a reduction in specificity, and of course the specificity of serum is 100%. So we do get a slight increase in accuracy, but the key area is this one here, where colostrum was able to identify 3 out of 4 of those positive fecal culture animals. So the conclusion, what can we conclude from this? We'll be very careful. Again, I want to re-emphasize, because we have very few positives, this is very limited amount of data. But notwithstanding, in this herd, certainly the colostrum performed much better than the HT-PCR. It was able to identify 3 out of 4 of those positive animals, although there was a slight reduction in the specificity of that sample type. There is self-evidently a lot more work we need to do to characterize this, but I think there's a slight hint that colostrum may provide an improvement in the sensitivity when it comes to the MAP ELISA. We've looked at this in other disease, and we've taken this concept across and looked at other things, and we have got some fairly good results using colostrum as opposed to serum with ELISA tests. We're certainly interested in expanding this work across Yonis, but there is some interesting now antigenic arrays being developed for TB, and we do wonder whether colostrum might provide an advantage across those new developed array antigens with regards to the sensitivity they might provide, or that sample type might provide. Colostrum as a sample, is it easy to collect? Yes, farmers can collect it. You can store it at -20 in an ordinary freezer. The downside is, of course, you can only collect sample with animal calves. And of course, there is variation depending on the time point from calving when, in terms of the amount of immunoglobulin concentrations that you find in that sample type. I'd just like to acknowledge the state lab, the accredited state lab that did the HTR work and the fecal culture, and also the veterinary surgeon who took the samples from us on the farm. We have published this work. I've just labelled it there. So this work was published in 2015. Thanks very much.